All right. All right, make sure you have a date in the top right-hand corner. And the reason I'm saying that is because there are times when I will give you a grade for your notes. And when I'm giving you a grade for your notes, maybe your title looks different from mine, but if you got the right date, then you'll know that's what I'm talking about, right? So you're giving yourself different ways to figure out what assignment I'm looking for. All right, so our title for our note should be Unit 1, and it's going to be Solving Equations Practice. All right, let's get started. So, Leon, can you distribute this for me? Thank you. Make sure everybody gets one. All right, so let's start off. You can start with me. Let's go ahead and write down number 2 is the one we're going to start with. You may put your name on those. All right, number 2. It is 4x minus 3 equals 5. All right, what is always our goal, people? To get x by itself. And what is around the x that we need to get rid of? 4 and negative 3. Which one are we going to get rid of first? 3 or negative 3? Why negative 3 first? Because it's farthest from the variable. Excellent. So how do I get rid of, or how do I undo a negative 3? By addition or a positive 3, right? And whatever I do to one side, I must what? And what property are we using right now? Addition. Oh, very good. Those cancel out, and I'm left with 4x equals 8. Thank you, baby. Am I done? Why am I not done? Because I still don't have x by itself. What is around x that I need to get rid of? This 4. What is the relationship between 4 and x? Multiplication. How do we undo multiplication? Division. So I'm going to divide both sides by what? 4. Wes, what happens to my 4s? Wes. And what is that going to leave me? X. X. X equals 2. Everybody agree? Yes. Yeah. Very good. That was pretty easy, right? Yeah, how we feel about that? Good? All right, pretty simple. Let's go through and justify our steps. We got line 1, line 2, and line 3. What is line 1? It is given. What is line 2? Addition whole. And then line 3, division code. Are there any questions? Everybody good? Any questions? All right, let's roll. All right, so I want to check it. X equals 2. What is that? It's the solution. And solution is the value that makes the sentence what? True. So let's go check and see if it makes it true. When I'm checking, am I solving? What am I doing? I'm evaluating by plugging it in. Very good. I'm evaluating. What do we call that process of plugging something in? Substitution. All right, so I'm going to start with the original problem, which is 4x minus 3 equals 5. This is the original problem, or what was given. What's going to be my next step? Substitute. I'm going to plug in what we say. If x equals 2, then 2 can replace x. Almost like symmetric, right? where if A equals B, then B equals A, but because we're plugging it in, if A equals B, then B can replace A, right? So in place of X, I'm gonna put a 2. So this is gonna be 4 times 2 minus 3 equals 5. And my justification is this was substitution. Any questions? All right. Am I looking for an unknown? No, there's nothing missing here. We have no variables. So now I'm just gonna simplify, right? What do I do first? I got multiplication and subtraction. What do I do first? Multiplication. What's 4 times 2? 8. And so I'm gonna write 8 minus 3 equals 5. What am I going to call that? How am I gonna justify that? The whole process is evaluating because I plugged it in. It is equivalent equation. Good job tonight. It's equivalent equation. Is line 2 any different than line 3? No, isn't it the same thing? I didn't add, subtract, multiply something to both sides. It's the same exact thing. So this is just simplifying. And anytime it's simplifying, we're going to call that an equivalent equation. I'm just writing an equivalent equation. All right, what I'm going to do next? I'm going to add. I'm going to subtract. What's 8 minus 3? 5. So 5 equals 5. And again, is line 3 any different than line 4? No. So what do I call that? Equivalent equation. All I'm doing is simplifying. Excellent. Does anybody know what it's called when we have something equal to itself like that? It looks exactly the same on both sides. What is it called? Like terms. Ooh. Okay, let's talk about that. Watch this. If I got 3x plus 5x equals 10. You see what I got, Wes? 3x plus 5x equals 10. 3x and 5x are like terms, right? Because they have the same variable and the same imaginary exponent of 1, right? So that makes them like terms, which means I can combine them. You can always combine like terms. 3x plus 5x becomes 8x. Does that make sense? All right. Now this, what property is this? Is this a true statement or a false statement? True. It's true. And does 5 equal 5? Yes. But what property says something equal to itself? It is a property of equality, but which property? Is it symmetric? Symmetric says if A equals B, then B equals A. It's 2 different things. This is the exact same thing on both sides. It's like looking in a mirror. It is the reflexive property. Whenever I substitute in a value and I end up with the reflexive property, I know that my solution was correct, or the value of the variable that I chose was the solution. Are y'all with me? All right, so let me erase this because I just wanted to clear that up for Wes. All right, we're gonna look at another number. Anybody got questions on this? Everybody comfortable? Yes, boo. You're doing what I'm doing. All right, let's look at number 4. Number 4 says 3/4 x plus 1 equals -11. 3/4 x plus 1 equals -11. Yeah, but I mean, I gotta get up and open the door. You might be there a minute because I'm on a problem. You're welcome. Is this you already been already? This your second one for the quarter? Oh. Drawing the line. We ready? All right, what am I solving for? What's around x I need to get rid of? What is it? 1 and 3/4. Nothing different. We got to get rid of the coefficient and this 1, right? Which one are we going to get rid of first? Why? Because it's furthest away. So how am I going to get rid of a positive 1? -1. And what if I do to one side? I must. So now these cancel out. And what am I left with? Tell me what I got. 3/4 x. Don't be scared to say it because it's a fraction. 3/4 x equals. Ooh, let's talk about that. So what is this? -11. So let's say I use x's for negative. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You agree that's -11? Okay. Now what is this? -1. So I'm gonna put a -1. If I combine them, what do I have all together? -12. Do they become positives? No. Did one of them disappear? No. You got negatives plus more negatives plus negatives. It's just more negatives. Are y'all with me? All right. So this becomes what? -12. I got a question. Is this the same or different from this? It's the same. Why? Because the 11 is what? Negative. And the 1 is also what? Negative. What about this? Is this the same or different? Why? Y'all just saying same just because you think it is, or that says -11 plus -1. I use the parenthesis. You can't put that's not multiplication if you got a plus sign there, right? It's just separating the plus from the minus sign. So this says -11 plus -1. Is that the same or different? The same? Why? How do you know that? Negative plus negative is bigger negatives. What's in front of this 11? Negative. What's in front of this 1? Negative. Isn't that the same thing that was happening here? Yes, it's the same exact thing. Same thing. What about this? Same or different? Same exact thing. Why? Because the 1 is what? Negative. It was negative here. The 11 is what? Negative. It was negative here. Same thing. What if I do this? Same or different? Why? What's positive? The 11. And the first time it was what? Negative. Do we understand these signs? All right. So we got 11 negatives plus one more negative is going to give us what? 12 negatives. You went? Put that door out real quick. Quickly. All right. We good here? Everybody good? All right. So now, am I done? Okay, pick it up, put it back. Am I done? No. I still got to get rid of what? 3/4. How am I going to get rid of this 3/4? Well, let's talk about it. I want to show you something. Just give me a second. Watch. I'm going to go back a little bit to bring you back forward. Read this for me. What does this say, Chris Ann? What does this bar mean? That means multiply. So read it again for me. It's okay. It's all right. Boys and girls, but okay, we're not gonna do that. Help me out. What is it? You're reading the problem. Isn't that what that is? Do y'all see that? This is actually 5 times 4 divided by 5. That's what it is. We were running from fractions like they something like foreign. It's just a division problem. This says 5 times 4 divided by 5. That's it. What? Yes. There's 4 there. So watch this. What is 5 times 4? 20. bring down divided by 5. What do we get? 4. So this actually comes out to be what? 4. It was just that simple. Right? We make it complex. It's not that complex. Watch this. Let me show you something else. What if I take this 5? I got a fraction here. I want to make this a fraction. How do I make this a fraction? What do I got to do to it? 5. Well, I want to make this a fraction first. So what do I do with it? Put a 100. So I'm going to put 5 over 1 times 4 over 5. Do you agree that this is the same problem as this? Yeah?
Yes.
All I did was put it over 1, right? What's 5 divided by 1?
5.
So isn't that the same thing? Yes? So now watch. What do I do now? 5 times 4 is what? 20. 1 times 5 is what? 5. Now what does this say? Which is what? Did I not get the same answer again? I did. Are y'all seeing that? All right. Let me try one more thing. Watch this. 5 over 1 times 4 over 5. What would you do if I had 5 over 5 times 4 over 1? What would you do with these two? Okay. Okay, I can make them 1. And then 1 times this will still be this, right? So couldn't I just do this? Could I cancel them out? I mean, think about it. Y'all look like y'all not sure. But when we go here, what did we do when we had a 4 in the numerator and a 4 in the denominator? Right? So aren't I doing the same thing? Why were we able to cancel it out? Because 4 divided by 4 is really 1, right? Well, what's 5 divided by 5? 1. So can I just cancel that out? So what am I left with? 4 over 1, which is what? 4. Can we get the same answer again? It's all the same thing. It's not complex. But here's the point that I'm trying to make to you. That when a number is in the numerator, we're multiplying by that number. 5 times 4. When a number is in the denominator, we are dividing by that number. Are y'all with me? What is the opposite of multiplication? And what is the opposite of division? If you see a number in the numerator, that means we are doing what with that number? Multiplying by it. If you see a number in the denominator, that means we are doing what with that number? Dividing. Keep that in mind. Watch this. Let's go back to this problem we got. We got 3/4 x equals -12. Read this for me. Now that we've done all we just did, read this. X times 3. Isn't that what that say?
Yes.
That's it. It's saying x times 3 divided by what? 4. Now watch this. I want to get rid of this fraction. But I know it means that we're multiplying by 3 and dividing by what? 4. So if I want to get rid of this fraction, I need to do the opposite, right? What is the opposite of multiplication? And what's the opposite of division? So then that's what I'm gonna use. So watch what I do. If this is multiplying by 3, I'm gonna do what? So where am I gonna put it? Underneath, in the denominator. Sorry. Right? Why? Because they're multiplying by 3, so I'm going to divide by 3. And they divided by 4, so I'm going to multiply by 4. Now what can I do? I can cross them out. Can't I? Can't 4 cancel with 4? Because I got 1 in the numerator and 1 in the denominator. And 3 can cancel with 3. Now it's gone. Y'all see that? What do we call 3 over 4 and 4 over 3? They have a name. What do they call? Well, y'all know it starts with an R, don't you? That's what you said? What you say? Oh, you said order pair. No, remember order pair has a comma in between them, right? And it's an X and a Y in parentheses. Nuh-uh. What do we call these? They start with R though. Not a relation. Relation is a list of ordered pairs, and this is not an ordered pair. How about this? Y'all know that word? Reciprocal. Y'all remember that word? Who heard that word before? Reciprocal. What is a reciprocal? It is just a flip fraction. So what is the reciprocal of 1/2? That's it. What's the reciprocal of 4/3? You see that? So didn't I just take this and multiply by the reciprocal? This was 3/4. How do I divide by this fraction? I'm gonna multiply by the reciprocal. And whatever I do to one side, I must what? What did I multiply this side by? 4/3. So what am I gonna multiply this side by? 4/3. Whatever you do on one side, you must do to the other. Does everybody understand why I multiplied by 4/3? They multiplied by 3/4. Are you with me? But that 3 was in the numerator. So to get rid of it, I had to put it in the what? Denominator. And they divided by 4. That 4 was in the denominator. To get rid of it, I got to put it in the what? Numerator. Now I can cancel them out. And whatever I do to one side, I must what? Do to the other. Isaiah, you look confused. Put words to it. Okay. It's okay. Whenever you gather yourself, let me know what you don't understand. All right, let's keep going. So what do I have left here? X equals. Now it's just multiplication. What do I want to do with this 12? But before I do that, I want to do what? Put a 1 under it. Now I want to do what?
Multiply the 12 by 1.
What kind of 12 is this?
-12.
What's a negative times a positive?
Negative.
A negative. And what's 12 times 4?
48.
48. Over,
3.
but over 3. Now we're going to divide it. Last step, x equals what?
-16.
Negative 16. Very good. Thank you, Ricardo. Any questions? Now, I know it might not have went down well, right? That was our first lift. But let's lift again. Y'all ready? The more we do it, the easier it gets, right? Okay, let's try another one. Put on your paper example 1. I'm jumping off the worksheet for now. I want to practice some more. Matter of fact, let's put a note on the bottom of that paper we just did. What is the thing we want to take away from this? Is what is the relationship between 3/4 and x? They side by side. So what does that mean? It's multiplication. And how do we do multiplication? Undo multiplication. Division. So here's what I want you to write. 2 divide by a fraction. Multiply by its reciprocal. So to divide by this fraction that we got here, this 3/4, we need to multiply by its reciprocal. And the reciprocal of 3/4 is 4/3. And then whatever we do to one side, we must what? Do to the other. Does this note we just made make sense? Yes? All right. Yes? Yes? All right. Let's try a problem. Let's do example 1. I'm gonna throw in something. Oh, Lord. 4/5 x minus 6 equals 2. All right, let's go. What we got? What's my goal? Draw my squiggly. What's around x I need to get rid of? -6 and 4/5. Which one am I gonna get rid of first? -6. How do I get rid of a -6? I'm gonna add 6, +6. So I'm gonna put +6, +6. Draw my line. Everybody good there so far?
Yes.
What happens to -6 and +6? I should never see something canceling out that don't have different signs. The signs must be opposite for them to cancel out, right? All right, now, what do I have left from left to right? What do I have?
4/5.
4/5 x equals
8.
8. Y'all with me? Am I done? What do I still need to get rid of? X. Do I need to get rid of X? What do I need to get rid of? 4/5. What's the relationship between 4/5 and X? How do we undo multiplication? Divide, we're not going. Yes, no, almost. How do I get rid of multiplication? By division. How do I divide by a fraction? How do I divide by a fraction? Multiply by its what? Reciprocal. Very good. I understood what you wanted to say. I got you. So what's the reciprocal of 4/5? 5/4. And whatever I do to one side, I must what? So I'm gonna immediately write this over here. Now, what happens to 4 and 4? Cancel out. What happens to 5 and 5? Cancel out. What did that leave me? It leaves me X. Yes, sir.
How do they cancel out if they don't have different signs?
Because it's multiplication versus addition and subtraction. If these would have had different signs, the answer would have been negative. We're not doing those kind of signs. I'm gonna show you. Watch. What's 5 times 4? 20. What's 4 times 5? What can I do with this 20 over 20? Even though they don't have different signs. You understand what I'm saying now? Good. Thank you for asking that question. That was a good question. Equals. What I'm gonna do on this side? Fix your face. I'm not playing. I don't like that. In here, everybody can ask me whatever question they want to ask me. You got to do with my math, and nobody's face should be squinched up, don't understand, feel a kind of way. They talking to me. So I don't like that. Everybody in here should feel comfortable to ask me whatever they want to ask me. There are no dumb questions. There are no any questions that I don't get, like they shouldn't be not getting it. No, that's what we in here for. And remember, all y'all on the same level. So if you squinching your face up at somebody, why are you in this class? Because you score what they score. So everybody on the same level. So nobody ain't got no grounds to talk about nobody. Everybody in here the same score. Am I clear? Am I clear? Okay. We're going to treat each other like we're trying to help each other because that's how we're going to get up out of here. So what do I do with this 8? Put a 1 under it. Now, what is the math problem that I want to simplify? What am I doing? Multiplying 8 times 5. Everybody see that? What is 8 times 5? 40. See how fast people's faces can squinch? And what's 1 times 4? 4. Are we all good here? We can move on. We got more to do? What else can we do here? Very good, because this is not simplified. So now we got X equals, what's 40 divided by 4? 10. And now we're done. Absolutely. Was this one a little bit easier than the last one? Yes, good. Question. That answer won't be found. Do we know it's right? Yes, because what does it say? 40 divided by 10. 40 divided by 4, which we know is 10, right? But if they ever had this on a test and they ask you to pick the answer, you will never see 40 over 4 because they only present to you things that are fully simplified. Okay? So if you get here, but you see 10 on the paper and you know that's 10, then yes, but they won't show you that. That's a good question. They always simplify all the way out. All right? Everybody good here? All right, let's do another one. Example 2. I wanted to get like easier. We got to be lifting this weight faster, right? So we can move on. All right. Let's do -10 minus 1/3 x equals -19. Sorry. How y'all feeling? Seem difficult? Because they got all these minuses in it? Same thing. What do? What's the first thing I want to do? Y'all don't know me about that? I want to draw my line. All right, what are we solving for? X. What's around X? Not 19. We know what 19 is. You just said it. What do we say? Mistakes are what? Eric. Mistakes are what? Eric. Mistakes are what? Eric. ERIC. What does that mean? Mistakes are expected, respected, inspected, and then what? Corrected. So when I ask you mistakes are what y'all gonna say? Error. Expected, respected, inspected, and then they are corrected. That's what we're doing here. We are right with mistakes, right? I done made like 3 already. Y'all ain't catching them. All right. So we got -10 minus 1/3 x equals -19. What am I solving for, class? X. What's around x I want to get rid of? -10 and -1/3. Hey, don't be bored. Participate. What am I getting rid of first? -10. How do I get rid of a -10? +10. So what am I going to do? Add 10 to both sides. So I'm going to add 10, add 10. What happens to -10 and +10? Cancel out. Being cute ain't going to do nothing for these grades. I'm just saying. You real cute, going to be real cute and failing. At least I'm cute, though. Come on, let's get this stuff done. What do I have left over? -1/3 x equals, ooh, -29? That's what it is? What is it? Let me ask you something. What did it say? +1? What's that? What happened to +1 and -1? Cancel out. Okay. So +1 and -1, they cancel out. They're called a zero pair. What is this? It's a zero pair. It's what? -3 and what? +3. So if I got 1, 2, 3, +3, and then 1, 2, 3, -3s, I got 3 zero pairs. They cancel out. Right? If I give you $1, that's +1. If I take the $1 away, that's -1. How much you got now? 0. So adding 1 and taking 1 away leaves you back at 0, right? Look at the number line. Start at 0. If I go 1 to the right, that's what? +1. If I go 1 to the left, that's what? Where am I back at? 0. Y'all see that? So +1 and -1, when you put them together, what do you end up with? 0. Y'all following me? You sure? Because I got some faces that's still not sure. You with me, Chrisanne? Yes? You sure? Okay, so watch this. What did we do right here? What is this? Negative what? -10. Watch this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? -10. What's this? +10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What -10 and +10, I mean, -1 and +1 gonna give me? 0. What about this one? What about this one? How many of these zero pairs am I gonna have? 10. That's why this cancels out. Are y'all with me? So keep that in mind. What do we have here? What is this? So what does that mean? I have 19 what? Negatives. What did I have right here? 10 negatives? 11, 12, 13, 14, 15, 16, 17, 18, 19. Now I got 19 what? Negatives. And I got how many positives? 10. How many zero pairs am I going to have? 10, which is gonna leave me what? 9 negative. Does that make sense? Calculators, put them in front of you.
For the fractions, if it says negative, look at the top part negative or the bottom part.
Good question. I'm gonna show you in a minute. Hold on to that thought. That's in my plan to show you. In your calculators, do this for me. Put 19 and then hit the plus or minus key at the bottom. Now read this. It says negative 19 plus. So put plus 10 equals. What we get? I mean, I'm just saying, right? So what do we get? Negative 9. Everybody good there? All right. Now, am I done? Because I still got to get rid of what? X. Well, we keep saying X. Y'all trying to get rid of X.
-1/3.
Negative 1/3. Our goal is to get X by itself. So I ain't trying to get rid of it. I need it to stay, right? So what do we need to get rid of that's around the X? Negative 1/3. There's 3 ways you can see this. You might see -1/3. You may see 1/-3. Or you may see a negative out front with a 1/3. Either way, they all say -1/3. Why? Because what's a negative divided by a positive?
Negative.
A negative. What's a positive divided by a negative?
Negative.
A negative. So they all still what? A negative. So if you're asking which one of these are negative, you make whichever one you want to be negative. The only thing you cannot do is make both of them negative. Because what's a negative divided by a negative?
Positive.
And this is not positive. So you can either make your 1 negative or your 3 negative. It won't change your answer. Did I answer your question? Great. Now, what is this saying? X times -1 divided by 3. Do we agree? This is X being multiplied by -1 and divided by 3. Yes? So what is the reciprocal of that? It could be -3/1, or it could be 3/-1, right? So 1/3, -1/3 is being multiplied to X. How do I undo multiplication? Division. How do I divide by? Girl, you went cross on me twice. That's what your eyes doing. You sleep. I need you to wake up. Head off hands. How do we divide by a fraction? Multiply by its reciprocal. What's the reciprocal of -1/3? 3/-1 or -3/1, whichever one you want. And whatever I do to one side, I must what? So over here, I'm gonna put 3/-1. This is insane. Why y'all class always finish way before everybody else? Do y'all know I did this problem and it took me to the bell for the last 2 classes? It took me to the bell. I'm starting to think that, like, seriously, because this is the class the last time, right? That I was like, well, I'm finishing way before everybody else in y'all class. Yeah, this period ain't longer. That's crazy. Like 20 minutes before everybody else. Okay, whatever. All right, let's go. So we got 3 over what? -1 times -1/3. What's gonna happen? These cancel out and what? These cancel out. And what does that leave us? X equals. But before I do that, what I want to do with this 9? Put a 1 under it, right? So now I got a negative times a positive is a what? Negative. And 9 times 3 is 27. That's all right. And then I got a positive times a negative is a what? Negative. And then 1 times 1 is what? That was harder than the first one. So now we got X equals, what's a negative divided by a negative? Positive. 27 divided by 1? 27. Damn. 27. Are we all good there? Any questions? All right, let's check it. All right, so to check it. We're gonna start with the original problem, -10 minus 1/3 x equals -19. Tell me what to do to check. What did we just find the solution was? Go ahead, Chrisanne, with, We're gonna replace x with 27. Everybody understand why? Yes, all right, so we got -10 minus 1/3, and we're gonna replace x with 27. What property are we using?
Substitution.
Substitution. So this is the original problem or the given. And this is substitution. What I'm gonna do next? Am I gonna draw my line and then add on both sides and all? No, because we ain't solving. What are we doing right now? Evaluating. So tell me, what do I do right now? Right now, I'm just following PEMDAS.
5.7
Excellent. By -1, right? This is subtraction and this is multiplication, isn't it? Which one do you do first? Multiplication. What I want to do with this 27? Put over 1. So now I'm gonna do multiplication before I do subtraction. So I got a negative times a positive. That's a -1 times a positive 27. What is that gonna be? So I'm gonna bring down my -10, then I'm gonna put -27 over 3 equals -19. Any questions? Now what? Good. I'm gonna divide -27 by 3. What's a negative divided by a positive? Negative. So I'm bring down my -10. Then I'm gonna have a negative. And what's 27 divided by 3? 9 equals -19. Now we're here. Read this from left to right. What does it say? -10 minus 9. Give me the two integers that you see. What's this one? -10. What's this one? -9. I got 10 negatives
Or 10, 9.
and 9 more negatives. Here's my question. Do I have any zero pairs?
So,
No, because to have 0 pairs, you need negatives and what? Positives. So I only got negatives. So -10 is 10 negatives. -9 is 9 more negatives. So what I'm gonna end up with? -19. So this is -19 equals -19. Is that a true statement?
Yes.
Yes. So that tells me what? That my solution is -19?
So,
No. What does it tell me? That x equals 27 is the correct solution. Are y'all with me? Everybody follow? All right, let's justify these lines. Good afternoon, this is Stampley. Hi. Nope, you gotta call my number to get him. No problem, baby. No problem. You're welcome, sweetheart. Bye-bye. All right, we ready? All right, so what do we do here? We did subtraction, it's a substitution here. Then what do we do here? But isn't this the same thing as this? So it's equivalent what? Equation. That's it. And what about here? It's equivalent equation. And what about here? Equivalent equation. If all I'm doing is rewriting the rule, rewriting the sentence, not adding into both sides, not subtracting or dividing, if I'm not doing a poll, then it's equivalent equation. Are y'all with me? Unless I'm doing something specific. Are y'all with me here? All right, now I want to give you a problem. Ooh. Y'all ready? All right, let's see how we do. The problem I am giving you is very difficult. Extremely. But I have faith in you guys. All right, here we go. -6 plus 2/5 x equals -2. what do we get? Yeah, you're doing it by yourself without me. Hey, love. Okay, no worries.